In solving a one-step equation, we are going to make use of the inverse. Why is that going to help us? Let's consider how to solve a one-step equation that involves addition. Suppose we have the equation x plus 4 equals 9. Now maybe you're able to just look at this equation and intuitively know the solution. If so, that's great. Our focus in looking at this equation, though, is to understand a process that will give us the solution even if the numbers are a little bit more awkward than this. Our goal is to get an equation of the form x equals a number. And since there's addition going on, the way that we want to make that happen is to get an equation in the form x plus 0 equals a number. Because 0 is the additive identity, we'll then be able to just forget about the 0. So the question we're going to ask ourselves is, what can I add to 4 in order to get 0? We will answer that question by saying, it's additive inverse, of course. That's always what we can add in order to get 0. So we take our equation and we add negative 4 to both sides. We'll have x plus 4 plus negative 4 equals 9 plus negative 4. Our properties of addition let us drop those parentheses on the left and group the 4 and the negative 4 together. On the left we'll have x plus 0, or just x. On the right, 9 plus negative 4, thinking that's 9 minus 4. We get x equals 5. Note also, since x equals 5 has only the one solution, namely x does represent the number 5, and all of the equations that we've written in this process are equivalent, we know that x equals 5 gives the only solution to our original equation, x plus 4 equals 9. Thus we've successfully solved the equation because we know for sure that x equals 5 is the only solution. Remember that to solve an equation meant to find all of the solutions and to know that we've found all of the solutions. We can, if we like, write down this procedure generally. To solve the one-step equation x plus a equals b, we add the number negative a to both sides, and then simplify. But we don't need to memorize this procedure. Instead, we should focus on our goal. Remember that our goal was to get x plus 0 equals a number. We thought, what can we add to 4 to get 0? And we realized that we could use its additive inverse, negative 4. We need a short note on subtraction, and that is that if we see subtraction, we should rewrite it as addition. So for example, if we wish to solve x minus 5 equals 3, we should rewrite this as x plus negative 5 equals 3. And now we know that negative 5 plus its opposite, positive 5, will give us 0. So we want to add 5 to both sides. X plus negative 5 plus 5 will equal 3 plus 5. Using the properties of addition, we can get rid of these parentheses on the left, and if we like, put in new ones. Negative 5 plus 5 really is 0. And so we get that x equals 8 is the only solution. So we don't need a separate procedure for dealing with subtraction. We can just rewrite it as addition.